Okay. We have now, also this is the process of adding oxygen to a substance. Now when you look at this second example, we have this is what do we call this? This is nitrogen 2 oxide. Nitrogen 2 oxide reacting with oxygen. Abi? We have nitrogen 4 oxide. Do you know why it's called nitrogen 2 oxide and nitrogen 4 oxide? Any idea? We do that based on the oxidation state. But you will see that when you look at this, you will see that this is oxidation reaction. Abi? Because oxygen is being added to this NaO3, which produces what? NaO2. Are you with me? These equations, are they balanced? Yeah? The equation is it balanced? If you look at magnesium, magnesium is 2 here. We are doing what we call atom count. Magnesium is 2 here. Magnesium is 2. This 2 that is here is guiding this, is affecting this, and also affecting this. Are you with me? So in this case, magnesium is balanced. Oxygen is 2 here. Oxygen is 2. Oxygen is balanced. So therefore, the equation is balanced. Look at this one. NaO. This is NaO. Nitrogen here is 2. Go to the product side, nitrogen is 2. Nitrogen is balanced. Oxygen is 2 here. Oxygen is 2 here. 2 plus 2, 4. So at the left hand side, which is the reactant side, oxygen is 4. At the right hand side, oxygen is 2 here. 2 here, 2 times 2, 4. So oxygen 4 here, oxygen 4 here, therefore oxygen is balanced, and therefore the equation is balanced. And now, I hope it's clear. Yes. Now, we go to the second definition. Please note this thing. They will look at the way they may ask you this question. They may ask you identify if the equation is an oxidation reaction or a reduction reaction. So when you look at this, even now that you have seen that oxygen has been added to magnesium, and we have this magnesium oxide. This one, this is nitrogen 2 oxide. Do you know how we get it to be 2? I said this is called nitrogen 2 oxide, and this is called nitrogen 4 oxide. This is as a result of this. Watch. Look at this guy now. Watch. This is NO. I want to get the oxidation number or oxidation state of this nitrogen. So we have NO. This is NO, and this NO, just add it and equate it to 0. So you have N plus 0 equals N plus oxygen equals 0. You have N. The oxidation state of oxygen is what? -2. Which will give us 0. So you have N, open the bracket, N plus -2, it will give us 0. You have a plus times minus will give us -2 equals 0. Then collect like times N equals to what? 2. And this 2 in Roman figure is called II. This is why this is called nitrogen 2 oxide. Are you with me? Yes. For the case of this guy, this is NaO2. If you stop now and equate it to 0, please be knowing all these things because it's coming. It's going to come. Just know it so that when you have difficulty in it, you just do it and know the correct stuff. Now, if you have NO2, you add and equate to 0. You have N plus O2 equals 0. M plus these 2 comes up here, 2O equals 0. M plus the oxidation state of oxygen is what? -2. That's 2 bracket -2 equals 0. You have M plus, open the bracket, 2 times -2 give us -4 equals 0. First times minus is what? Minus, you have n minus 4 equals 0. Then, for then items, you have n equals what? 4. And 4 is called IV. This is why this is called nitrogen 4 oxide. Take a here. You will solve it and get the oxidation number or oxidation state. Then from there, it will now be called either nitrogen 1, nitrogen 2, or nitrogen 3, or nitrogen 4, or nitrogen 5 oxide. Are you with me? Yes. Good. Take note of that too. We have indirectly learned how to calculate oxidation number and oxidation state. That is what I have taught you now. So given it, because this, if you check this to our past question, you will see where they ask you calculate the oxidation state of this. In this case, maybe when you know as in today, just know that the oxidation state of oxygen is -2. Are you hearing me? Yes. The oxidation state of oxygen is what? -2. Let it be registered in your medical because it will be coming. Later I will point the one of hydrogen. It will be coming. So that's all for that. We'll go to the second definition of oxidation. The second definition of oxidation, that is definition 2. That is definition 2. Definition 2. Definition 2. In that, we can see that, where is it? Oxidation, this is the process of removing hydrogen. This is the process of removing hydrogen from the substance. This is the process of removing hydrogen from a substance. Examples. Number 1. Okay. Second definition of oxidation. Also, this is the process of removing hydrogen from a substance. Examples. We have hydrochloric acid reacting with manganese 4 oxide, MnO2, manganese 4 oxide. It produces manganese chloride, water, and the chlorine gas. Are you with me? So in this case, let us verify if it's indeed oxidation in terms of removal of hydrogen. Like this HCl, hydrochloric acid, are you seeing the hydrogen here? After the reaction, are you seeing this young man? Are you seeing chlorine? Are you seeing chlorine? If you check very well, you will discover that chlorine have left. So you discover that hydrogen have left chlorine. In the reactant side, chlorine is not alone, but from the answer we have now from the product side, chlorine is what? Alone. That is to tell that hydrogen has been removed from this chlorine. So in this case, we say that this is what? This is oxidation reaction because hydrogen has been removed. So as far as you have believed that this definition is based on removal of hydrogen, where you look at is that particular substance where hydrogen has been removed. Are you with me? Are you with me? Yes, sir. Take notes because we are going to solve past question. Look at example 2. Hydrogen sulfide gas. Do you know what is hydrogen sulfide gas? It has the smell of a rotten egg. Look at hydrogen sulfide gas reacting with chlorine atom gas. When you check very well, you will see that sulfur is alone, which indicates that hydrogen have left sulfur. Are you seeing it? Yes, hydrogen has been removed from here. So in this case, we say that it is an oxidation reaction because don't look at this two. When the liners a hydrogen have been added, no, this is where you look at. Just look at the reactant side and check the two elements that are involved. What happens to them? As far as this is not alone, and here now it is alone. In this case, oxygen has been removed from sulfur. So this is an oxidation reaction. Take note. This is the definition in terms of removal of hydrogen. Okay, we want to verify if the equation is balanced. Now we're going to do what is called atom count. Please watch. We're going to be doing atom count of each of the elements. The first element we have here is what? Hydrogen. Hydrogen is 4 here. And because is there any other place you can say hydrogen? No. We go to the reactant side. Look at hydrogen. Hydrogen is 2 here, 2 here. 2 times 2, 4. So in this case, hydrogen is balanced. We visit chlorine. Chlorine is what? 4. Another chlorine yellow. We check the reactant side. Chlorine is 2 here, 2 here. 2 plus 2, 4. Chlorine is balanced. We check manganese. Manganese is 1 here. Manganese is 1 here. Manganese is balanced. Yeah? We check oxygen. Oxygen is 2 here. Look at oxygen. Oxygen is 2 here. These 2 is affecting H and O. Yeah? So oxygen is 2 here also. In this case, oxygen is balanced. Since all the elements are balanced, you know what we mean by being balanced? That is the number of oxygen at the reactant side must be equal to the number of oxygen at the product side. That's what we mean balance. Yeah? So in this case now, the equation is balanced since all the elements are balanced. Let us check the case of B. Hydrogen is 2. Hydrogen is 2. Hydrogen is balanced. Sulfur is 1. Sulfur is 1. Sulfur is balanced. Chlorine is 2. Chlorine is 2. These 2 is affecting H and C here. Huh? Chlorine is 2. Chlorine is balanced. Therefore, the equation is balanced. Is that clear? Good. Now, the third definition of oxidation says this is the process of adding an electronegative element to a substance. Imagine an element. We have metals, non-metals, and the metalloids. Abi? Yes. Metals are regarded as electropositive elements, while non-metals are regarded as electronegative elements. Now, the definition says that the process of adding an electronegative element to a substance is referred to as what? Oxidation reaction. As simple as that. Are you with me? Look at magnesium reacting with chlorine. Chlorine is a non-metal. And since it is a non-metal, it is referred to as what? Electronegative element. Are you with me? Naturally, non-metals are electronegative. Abi? Good. The process of magnesium reacting with chlorine to produce what we call magnesium chloride is referred to as what? Oxidation reaction. Are you with me? That's it. Look at this B. This is zinc reacting with hydrochloric acid. It produces zinc chloride and hydrogen gas, if they ask you to identify the type of reaction happening here, nickel level, this is zinc, a substance. And again, very well, you discover that during the process of reaction, zinc left this. Sorry, chlorine left this guy and went to join zinc. Chlorine is an electronegative element and has come to join what? Zinc. So in this level now, in this process now, the reaction happening is what we call oxidation reaction. Anytime electronegative elements, which are referred to as non-metals, is being added to a substance, automatically that reaction is what? Oxidation reaction. Are you with me? But no issues. But lazy again, they will not discover that the two is out. Yes. Now, the equation is balance. We go to the fourth definition. Now, this is the fourth definition. The definition says this is the process of increasing the oxidation number of an atom of an element in a compound. Example, we have 2FeCl2H plus chlorine atom, which gives us 2FeCl3. The arrow here is telling you that it is what? An oxidation reaction. Okay. Now, if you look at the example, you can see that the oxidation state of ion in this compound, in this ion 2 ion, is what? Is +2. You solve it, is +2. Now, if you check the oxidation state of this particular compound that is being produced, you will discover that it is what? +3. So in this case, there is an increase of the oxidation number of what? Ion, from +2 to what? +3. So here now, we can assume that this reaction is called oxidation reaction because there is an increase of oxidation number of ions. Is that clear?
Yeah.
Good. Okay, this is the process of losing electrons. Example, we have this. Note, this equation you are seeing here is an equation that is talking about the gain of. Okay. It's clear now. Huh? Where the light is. Wait. No, 2%. Okay, what you are seeing here is this equation is talking about gain of electrons, while this is talking about loss of electrons. The gain of electrons is called oxidation. So the loss of electron is called oxidation, while the gain of electron is called reduction reaction.